Okay, welcome to Rockin' Math, and let's talk about some Algebra 1. Best way to get started is let's look at the foundations. And what I mean by that is actually the language part, looking at variables and expressions. Well, why should you want to even learn this concept? Mainly because we can translate between words and numeric ideas, algebraic ideas. And for instance, if we want to know how many plastic bottles, if you're into this green earth, how many plastic bottles would it take to recycle enough to make carpet for a house? So algebra has its very important and, may I say, real world assets or concepts that we need to take under consideration as we march through our high school years. So let's just get on with it. Let's just get it on. As we said, we want to be able to take this lesson and be able to read a word problem and determine how we make this word problem literally into an actual algebra problem. Some vocabulary that we need to take a look at are variables, which is a letter or a symbol used to represent a value that can change. It comes from the word vary, which means that it could be something now or it could be something later on. Good example of a variable could be, let's see, x, or we can use y, or we can use g, or as you get along a little bit further, we can use h. So these are variables, and they're used to represent a value that can change. We also need to understand what a constant is, and that's a value that does not change. What I mean by a constant is 25. No matter where you place 25, 25 is 25. We could say 0. We can say 1. We can say 1/2. We can say 0.7. All of these values is constant. They do not change. Then we need to understand what a numerical expression. The numerical expression, it contains only constants and operations. So what we mean by constants, we're talking about 6 minus 2. That's a numerical expression. There's a constant and an operation. We can say 3 times 1. That's a numerical. 2 constants, 1 operation. And we also need to know what is an algebraic expression. And an algebraic expression contains variables, constants, and operations. So we could use, for an example, 2x minus 3. Notice something, no equal sign, just 2x minus 3, or we can say, let's say, x over 5. That's x divided by 5, and that is a constant, variable, and a divided by operation. So, but as we look at algebra, we need to be able to determine what certain wordings are so we can translate between algebraic expressions and words in a successful manner. So let's just give you what the 4 basic mathematical operations are, and take these basic operations and show you how we can add some words, not all, but some words. For example, plus sign. That means plus, sum, or increase by. So if you're dealing with a word problem and you see James had 5 apples plus 2 oranges, then you're going to add 5 plus 2. Or the sum, the word sum also can be used to talk about plus or addition. And what we say there, we can say that the sum of 5 and 2 will give us some value. Or if we see the words increase by, that again let us know that we are talking about addition. 5 increased by 2. Okay. The next one, let's take a look at minus, or should we say subtraction. When we see subtraction, some words to let us know that we're talking about subtraction could be minus. 5 minus 2, or the word difference. The difference of 5 and 2. Or we can say, use the word less than. Again, we're talking about subtraction when we say 5 less than 2. Again, we're still talking about taking the second number and subtracting from the first number. The next one that we want to take a look at for words, and again, please understand that these are just minor. These words are not the whole words, are all the words you'll look for. These are some words that will let you know what operation you're going to be using. Let's take a look at multiplication. So here, now something I want to show you on multiplication that you can see, you can use a time sign, but as you get off in the algebra, most of the time you're going to have that raised dot. We can have 2 raised dot 1. That means 2 times 1. But anyway, when we see words like times, if we see words like product, if we see words like equal group of, we're talking about, or the author is talking about, multiplication. Then as we look at, and we're going to go through here and make sure that we see examples of each one. Division, the division symbol. How do we know when we see words that's talking about division? Well, you'll see something saying divided by, or you'll see the word quotient. Again, when you see that, then your main thing, or your main analogy should be, hey, let's talk about dividing. Now, what I want to do is give you about 3-4 examples, and then I'm going to give you some problems and let you work those problems. And if you have any concerns with those problems, we'll address those problems in the next video right when we start, because this is going to take us about 3 or 4 videos to get through, so you can understand exactly what we mean by the language of algebra, especially with variables and expressions. So the first example I want to look at is x plus 3. So the direction says, let's translate from an algebraic symbol to words. So here it's pretty much the reciprocal of what we've done. It's giving us the actual algebraic, or the actual algebraic expression, and they're telling us, well, how do we say this in words? So we see x plus 3. You can say the sum of x and 3. You can say x increased by 3. You can say x plus 3. You can say x added to 3. All of those are the words to that particular algebraic expression. Then we have m minus 7. That's m minus 7. Well, even when you read these, you pretty much putting these in the word form just from what you're saying as you look at the problem. M subtracted by 7. The difference of M and 7. 7 less than M. You notice less than M. It didn't say 7 less M. It's 7 less than M. We could say M less 7. And here, now here, when we work with algebra, I want you to understand that you're looking at, according to what I see algebraically, that's 2, that x is times y. Very, very seldom as you go forward will you see that x, because that x can also, if we look up here, can also be used as a variable. So what I did when I put that here is I was using my keyboard, what did not have my raised dot, but normally what I wanted that to be, and this will pretty much be the way you see multiplication, is 2 raised dot y. I'm gonna tell you something else. You can also see this as 2y, and which will let you know anytime you see a constant and that constant is written not directly next to a variable, as in 2x, it means to multiply. So it's looking at 2 multiplied x, or 2x, or 2 raised dot x, or 2 raised dot y. We're talking about 2 times y. We can say the product of 2 and y. All of these will let us know that we are putting that into words from that algebraic expression. And the last one that we want to look at is division. Now, when you're dealing with keyboards, you'll see that little slash, so that'll be k divided by 5. It can also be written as k divided by 5, like that. But anyway, you're still looking at the quotient of k, first number, or the first actual term, and 5. So make sure you understand, when you read this, the first term will be your numerator, second term your denominator. Okay, very, very, very easy concept to look at, but what we want you to do is make sure that you understand, because we're talking about changing and looking at real world applications. So we're looking at real world applications. We're going to be dealing with sentences and paragraphs where we have to take those and change those into algebraic representation in order for us to solve the problem. So your turn. If you would, give me 2 ways to write each of the expressions in words. So what I'm doing for your turn, and you'll see this very often, I'll always say your turn, is I want you to look at 1, 2, sorry about that, 1, 2, and it should be, this is number 3, and this is number 4. Okay, so if you could look at these, work these out, and again, when I put the second part of this, I will start off with solving these problems, and you can see just how well you did. All right, let's enjoy it.